There, hopefully you can see that. So yeah, today we're going to cover how we can host containers on Azure. There are so many different ways on hosting containers and running containers equally. So throughout this talk, I have assumed some basic container knowledge, but as a small group, if you just want to kind of interrupt me as we go through, I'm happy to kind of clarify things, take questions and bits and pieces if we want to. But before we get too far into it, let me introduce myself. My name is John Kilmister, and I've been a software engineer, more recently an architect, focusing on C# and Azure for about 20 years or so in total. You can find me online at John Kilmister, that's Blue Sky and LinkedIn and various other things. And I've got a blog at blueboxes.co.uk where I've got more of this kind of content. And actually today I've posted sort of a write-up of this presentation, so this presentation in blog format as well. So before we start talking too much about hosting options in Azure, I just wanted to take a step back and talk a little bit about where we are with containers and containerization. Now, it's been around for quite a while, and it's great to see that there's really good adoption. In fact, in the development side of things, 80% of developers are actually using containers as some part of their development process. But this can mean a whole range of things. So we could just use containers for hosting our dependencies. We could run a whole development environment in code spaces inside containers. Or we could be using test containers. So there are lots of different ways we can be using them, but it is great to see that so many people are already on this, containers. However, there was also another report in 2024 which showed a slightly different story. And that showed that although 47% of people planned to put their containers into production, when it came to asking who had actually done it, it was as low as 12%. So we've got a situation where, and admittedly these are different reports, but we have 80% of people or developers saying, yeah, we're using containers in some form, but only 12% are using them in production. That's a huge discrepancy. So why do we get that discrepancy? Well, one of the things about using containers is that when you start talking about moving to production, we start talking about issues that we don't have to deal with in our local environment. So things like networking, resilience, security, all of those kind of considerations that you need in a production environment. And when you start talking about those, you think, well, how do I go about doing that? And you quickly come up to Kubernetes. And if any of you have used Kubernetes, it is a really powerful platform. But if you're coming to Kubernetes from a world where you've been using serverless, for example, and you're primarily a developer, not network admin, it can be really daunting. It has a really steep learning curve. I often think Kubernetes as another platform. It's like moving between Azure and AWS, for example. Everything's there. It's just got a slightly different name and it works in a slightly different way. So there's a really big and steep learning curve. And there have been many case studies of organizations that have started on a journey to move all of their microservices to Kubernetes, only later to kind of revert that decision and roll back because the overhead is so big. And I really like this meme that I saw before. It's like, and this is simply how you deploy on Kubernetes. And that's what it can really feel like for developers when you start bringing in something like this. You take what's something relatively simple as a handful of containers, and now you have to manage a huge amount of network infrastructure. And that's not to say Kubernetes doesn't have a place. It is a great platform and it is super powerful. But the key thing here is that although Kubernetes is an option, as with pretty much everything, it really does depend, and it is not the only option. And that's what I'm really talking about in today's presentation. We're going to go through 8 different services that Azure offers on how we can run containers. And we will look at the pros and cons of each of those. And yes, some of them are backed by Kubernetes. but really it's to help everybody understand that there is more to running containers in production than having to learn the entirety of Kubernetes. Before we start looking at those services, I just want a quick recap on containerization. Some of you might be really familiar with this, but maybe not so. So it's good to take a step back. And all of our containers start as a Docker file, a recipe for what, a recipe for what should be in our final container. So any dependencies, any libraries that we need, along with our application files, and a few things like exposing various ports. Great. So yes, so we start with our Docker file. And then we build our container image from that Docker file. Once we have that image, we then have to put it somewhere, because although just building a container image and running it works in our local environment, if we want to host it in production, it has to go somewhere. And we can put it in an artifact store. Now that might be something like Docker Hub, but equally it could be something like Azure Container Registry, which is maybe more of an appropriate place if we're going to be hosting in Azure. We're not going to go into the benefits of Azure Container Registry here, but we can talk more about that afterwards if you are interested. Now, sometimes your story around running containers in production might start at that artifact store. It may be that you're taking a SQL Server image or a MongoDB image directly from somebody else, and you're pulling it down from Docker Hub. Now, behind the scenes, it would have started life as a Docker file. It's just someone else's responsibility to keep that Docker file up to date. If it's our own application code, then it's our responsibility to create that Docker file, build the image, and put it into that artifact store. Now, before we can actually run it in production, we're more than likely going to want to run multiple containers side by side, and we're going to want to join them all together with various networking and routing options. And that's where container orchestration comes in. And depending on how we're hosting, it depends on how we do that orchestration. So it might be as simple as a compose file, or it might be as complex as a Helm chart. But we do have some form of orchestration definition, which is separate to our container. And then finally, we can take that and deploy it and run it. And as I say, there are many ways of running it, and that's what we're going to focus on today. Really, this second half, the orchestration, the deploying, and running. But I thought before we went into that, it was good just to do a quick recap. So onto the main part of the presentation. What options do we have? Well, actually, there's quite a wide range, and some of them you may have heard of, and some of them may be new to you. But we have things all the way on the left-hand side here that are completely serverless. You can just take your container and run it in the cloud. Azure Container Registry Tasks is one of these examples. It's not really a hosting option, but it does allow you to run the containers. We've got Azure Container Instances, one of the oldest container hosting services. Containers on App Service Plans. We have the newer Azure Container Apps. And then, of course, we've got Kubernetes itself, but we've got the Azure flavor of it. We've also got a set of specialist container support. So PaaS services that allow you to bring your own container to extend that PaaS service. Azure Batch, again, quite an old service, but it does support containers. So we'll briefly take a look at that and the use cases that you might want to look into that service a bit further. And finally, you can completely go it alone, and you can still put containers on virtual machines. So we'll finish off by taking a brief look at it. Now, all of these services have a different set of features, and we'll go through each of these one by one. Yep, great. So as I was saying, each of the services have different features and different pros and cons, and we're going to go through those in a bit of detail, but all of them kind of fit on this line between serverless, PaaS, all the way through to IaaS. So let's have a quick look at the difference between those, because these are some of the primary compromises. When we're looking at serverless, we are talking about something that is less complex to get started with. So you can just get going, you give it your container, and away you go. But It also means that you have less maintenance because you're not managing the underlying infrastructure in comparison to an IaaS solution, the infrastructure as a service. When we're going serverless, we have less complexity, we're quicker to get started, and there's a lot less maintenance. But it's not all benefits. Serverless typically comes at a higher cost. And when I say a higher cost, I'm talking about the cost per minute of the application running. Now, we can actually, serverless can actually work out overall cheaper because you can turn it off when it's not in use, and you can auto scale and things like that. Where in an IaaS solution, you typically have the infrastructure running more frequently. We might also have more costs than the IaaS side because we do have to do more maintenance. But on the actual price per minute running, we do have higher costs on the serverless than on the IaaS. Also, we have a lot less control on the serverless side. So depending on what you're trying to achieve, you might find that you want to use a service that is more to the right than the left of the diagram. But this could apply pretty much to any service in Azure that's serverless or IaaS, not necessarily containers. So let's look at each one of those containerized solutions. And we're going to do that by looking at the key terms. Each of the services, although often share features, use different terminology. We're going to look at the compute structure before looking at the features and, probably most importantly, the pricing model. Let's start with the first one, Azure Container Registry tasks. Now, you might not typically think of this as a way of running containers. Azure Container Registry is there to manage and look after our containers. We upload it to that, and then we can use the container in any one of the other hosting options. But it has this feature called tasks. And what that allows you to do is run scheduled jobs. And those scheduled jobs can be inside a container. So there's no setup of these. We'll have a look in a minute how we actually run them. But as long as your container is in the container registry, you can execute it under a task. It has limited features because it's more geared around a CI/CD process. So there's no GPU, no attached storage, no sidecars, and definitely no scaling. However, there are agent pools which are in preview, so you can kind of bring your own agent that give you some extra options. And they also do work on both Windows and Linux. The scenarios where these are used, as I said, are primarily CI/CD tasks, so using one container to build another container. But we can also use them to schedule maintenance tasks. So if you've got a maintenance tasks inside a container, you can just schedule that to run on a timer. And it's charged per second of that task running. And much like a CI/CD process, they run on these agent pools. There's one automatically provisioned for you, and so you can bring your own. So if we want to have a quick look at how we go about running one of these tasks, because this is one of the things that people I find often haven't heard of. The first thing to do is to get your container into Azure Container Registry. This is a relatively straightforward process. You can pull down an image, give it a tag of your ACR, and then push it up into your ACR. To actually run the container, we use ACR command, an Azure CLI command. It's not available to run this through the portal, although we can monitor it in that way. So as you can see here, we are doing an ACR run, passing in the registry name here, and then passing in the command, which is the image plus any arguments that we want. And when we execute that, what happens is that it queues it up on an agent, and it will pull down the image and finally execute that image. So you can see there it's pulling down the individual layers. It also will cache if it's needed, and as you can see, it's executed there with the output. These remote jobs are quite useful for doing remote container builds. So if you're on a Windows system and you want to build a Linux container, or you even want to build a Windows container and you don't have Docker Desktop installed, you can use these tasks to kind of pass it off and do a remote Docker build. That's obviously slightly different than running your container, but it is an option. And once we've got that task, we can actually see them on the left-hand side in the portal. So if we go down in our ACR to tasks, you can see the ones that are run there, and they're listed. I've used these previously and you can also see all the logs and things like that. I've used these previously to do cleanups of the images. So we can use ACR tasks to perform maintenance. But as I said, it's not really a proper way of hosting a Docker image. It is a quick way of running an image, and it's completely serverless. But let's talk a little bit more about how we can kind of host a Docker image. And for that, we're going to start with Azure Container Instances. As I mentioned, this is a part of the Azure platform that has been around for a long time. It's probably one of the oldest ways of hosting a Docker image. Now, the way these work is that you have something called an Azure Container Group, and that Azure Container Group is the compute layer. So everything that you put into that is all going to use the same CPU and memory. When you provision your container group, that is when you specify how much memory and CPU it has. And after that point, you can't change it. You have to destroy it and recreate it if you want to have a different amount of CPU or memory. So that does limit its functionality. However, as it is a service that's been around quite some time, it has a rich set of features. It supports service endpoints, private link, VNets, and public IP addresses. So the challenges, though, are that it doesn't have an easy way to set up an SSL connection, and it's not possible to scale it in any way. I mentioned before about the CPU and memory being fixed unless you redeploy the group, but it's also true that we can't scale out either. So you couldn't say, well, my website's getting more traffic, I want to put in more instances of it. So what is it good for? Well, it's quite good for running one-off background tasks. So you run a container with a job in it, it executes, and then it terminates. It's also quite good for hosting Azure DevOps build agents, which follow a similar pattern. So you deploy your Azure DevOps build agent into ACI, it executes, and then once it's executed, it will kill the container, and the container will auto restart, and you'll get a completely fresh build agent. I've also seen people use these programmatically, so it will spin up a new container group or multiple container groups to execute some batch work before destroying them. Okay, so yes, as I was saying, use cases for these are when you want to be able to run one-off tasks, but the key thing is they just won't work for any time you want to scale, so they're not very good for things like websites and things like that. And we're charged per CPU per second, and per gigabyte of memory per second. However, you can scale to 0. So if they're not running, if you've got a container group and it's not running, it's not going to be charged for. It does have GPU support, but however, it's not recommended to run GPU tasks anymore in that. So how do we go and create one of these? So I'm going to show you the Azure CLI tasks, mainly for brevity, but you can use Terraform, Bicep, and equally the portal as well to create them. And it's a single command to create the container group and also to place the container in it. If we want to, and once we've done that, we can then see that appear in the portal. And you get quite a lot of information in the portal. So we see the restarts and a bit of a event history. We also can see the properties. So you can see there the memory and the CPU allocated. And you can see the logs. One of the special features about this is we can also connect into it if your container supports it, if you need to debug it further. If we want to deploy more than one container into our container group, then we can use a YAML file to do so, and then we can pass that YAML file into the create command. The next thing I want to talk about is specialist images. I'm not going to go into a huge amount of detail here, but I did just want to flag it as another way of hosting containers. And what I'm talking about here, because specialist containers isn't an official title, it's just a grouping I've kind of put things together. What I'm talking about here are PaaS solutions that allow you to bring a container to enhance that. So for example, Azure Machine Learning allows you to bring a container with a model in it. So we're still using a PaaS solution, but we're bringing a container to enhance it. Things like Azure Databricks have slightly different offerings, and Azure Functions, again, slightly different again. But it might be something that you want to have a look into if you are interested in starting to use containers, but keep with a PaaS offering. So overall, they have a really good seamless integration with existing Azure services, but you are limited by the features that PaaS solution offers. So it really does depend on what you're trying to do. So let's look now at one of the other offerings, which gives you a lot more flexibility, and it's building on top of another Azure service that has been in the platform for some time, and that is Azure App Service Plans. If you're not familiar with Azure App Service Plans, it is a PaaS solution for hosting websites. You can take your ASP.NET application, put it into a zip file and upload it, and then it will just run. You don't have to manage the underlying infrastructure, and it comes with loads of great features, including free SSL certificates, deployment slots, and you have the ability to auto scale. And we'll actually talk about a few more of those things in a bit. Now, Azure App Service has been around for a while, as I mentioned. However, it's only in 2019 that they added in support for containers. The way app service plans work is that you deploy an app service plan, which is a set of memory, CPU, and disks, and that is your compute layer. You then add into that one or more web apps, Azure Functions, or web jobs. And the way containers on app service plans work is pretty much the same story. So instead of uploading a zip, we can attach a container to that. Web jobs have a little star there because under Linux they're now GA, but under Windows they're still in preview. But yeah, in essence, they're the same. They don't have any GPU support, and attached storage is limited to Linux only. But the main advantage is that it is a well-established PaaS solution. So you're getting your easy auth, your deployment slots, your free managed SSLs, and much more. One thing to note is if you're actually using app service plans today and you're deploying a zip package into a Linux app service plan, Microsoft actually wraps that zip package in a container and deploys it into the app service plan. So if you go and look at the logs, you'll see that it's actually running as a container, and Kudu, if you're familiar with that, actually runs in a sidecar alongside it. It's not the case if you're on Windows, but if you're on Linux, you're kind of already using containers. But this gives you the option of supplying your own. The main drawback, though, is because they added in containers after app service plans, it isn't as feature rich as some offerings. So, for example, health endpoint, you only get one health endpoint in an app service plan per web app. But if you're in the Kubernetes world, you could have multiple. It also doesn't support Dapper, and the key drawback is that all apps are going to scale together. So we saw the compute boundary and all our apps inside that. If we want to scale up to a larger system, or we want to scale out to have more instances, that affects every app in that app service plan. So it's not that well suited to microservices. Also, if we stop all of our web apps, effectively scaling to zero, you are still going to be charged for that underlying compute, that app service plan. So that can be quite a drawback if you are in a microservices system. But if you are running a public website that needs to auto scale without having to manage the infrastructure, they can still be a good option. And it's a great way, if you've got something on a app service plan today, you can move to containers and get some of the benefits of containers without changing your deployment platform. And as I mentioned, the pricing for it is that you buy an app service plan, which is CPU, RAM, and some preset storage, and you pay for that on a per hour basis. If we were actually to go and create one of these, well, we have to create our app service plan first, and then you create each web app that you want to put into it. But there are additional arguments now for the actual container image. Here we're just using a public image. However, you can also use an image in a Docker hub, passing in a username and password, or Azure Container Registry and using like a managed identity. Now, our container will be served to the public on port 443 or port 80 because it's a website, but it might only accept requests on another port, and we can override that through app settings, so environment variables, and there are a number of environment variables that we can apply. Now, with app service plans, we might want to run additional containers on that same compute, and that's often known as a sidecar pattern. And they had originally in preview supported compose files for doing this. However, a couple of weeks ago, they changed that, and they are actually bringing, well, you can try it now, sidecar support directly to the web apps. So if you've deployed a container under Deployment Center, you will now see an option to deploy a sidecar, and there are two ways of doing that. You can use a sidecar extension, or you can just bring your own container under custom containers. If you add a sidecar extension, then that's one of the pre-configured sidecars. So there's a Redis, Datadog, and some AI options. While if you bring your own container, you've got the full ability to bring whatever you want. Now, sidecars, if you've not heard of them before, are typically used for adding functionality to your app without interfering with it. So you might, for example, be publishing OTel data out of your app, and then you'd have an OTel collector as a sidecar, which may filter that log data down and then relay it on to a further OTel collector. Here, you also saw an example of caching. You can run that as a sidecar as well. And the sidecars run alongside the application for really good performance. So that's app service plans. So a great option if you're already using them and you want to start moving into containers. But I want to talk now about another service, which is relatively new in the scheme of things, called Azure Container Apps. And the way I look at these are that if you were to build app service plans today, with containers first, with a container first mindset, how would they look? And that's really what we're talking about here with Azure Container Apps. It's built on Kubernetes, but we don't have to manage any of the complexity that goes with Kubernetes. We don't even have to learn the terminology and Helm charts and those kind of things. So we have a Kubernetes-backed service, but with the ease of use of app service plans. And because of that, we kind of get the best of both worlds. But let's start looking at how they're structured. So we create an Azure App Container environment, and that is our compute boundary. There are two options for this container environment. We can either go dedicated, which is much more like the app service plan, or we can go serverless. But our compute boundary is the environment. We then have options of what we can put into that. We can put a container app, a container job, or a function app, or multiple of them. Again, that kind of feels a lot like we were seeing over in the app service plans, but there are some big differences. The first one is how they talk to each other. So when you add one of these apps to an app container environment, you get some options around how you want the networking. And unlike Kubernetes, where you would be specifying your networking in a Helm chart on an Nginx load balancer and various complex ways of doing that, we have just some simple options. Do we want traffic to be able to reach that container, or is it completely back-end? And if we do want traffic to reach that container, is it allowed from anywhere, from the public internet, or is it limited to just other apps in that app container environment? So we have a much simpler way of managing it, but equally, it's kind of secure by default because you have to make a decision about how you want your individual app in that environment to be exposed. And I think this is a really good example of where we've got the benefits of Kubernetes, but with the simplicity of the kind of thing that we'd see in an app service plan. So some of the other things that it supports, we still get the free custom SSL. We get some auth options. It supports Dapper, OTel, and loads of other cloud native technologies. There are add-ons which are in preview at the moment, which hopefully should expand it even further. The few drawbacks, if there was anything, is that there are no support for Windows containers at the moment. There's very few cases where you need a Windows container, and Windows containers have many disadvantages. However, if you do need Windows containers, you have to look at one of the other options. Also, the serverless pricing model may or may not work for you depending on what you're doing. It might be better that you have the dedicated plan, or you may find that you get better cost optimization through another option. So the main use case for this are cloud native microservices that have both back and front end or public and private apps in them, because they can all scale independently and live side by side, some being private and some being public. And the pricing model, if you're on consumption, is based on the virtual CPU seconds and gigabyte seconds in use. So how we go about creating them? Well, it's a very similar story. We create an environment and then we actually deploy our container app into it. Because we are sort of container first here, as well as specifying the image, we also specify things like the target port, and you have to specify how you want that ingress, if you want it public or not. I want to do a few more comparisons between app service plans and Azure Container Apps before we move on. One of the things that is good about app service plans are that you have these things called deployment slots. So you have your production code, and then alongside that, you can deploy another version of the code. And that allows us to swap the code in and swap it back if need be. We can also canary test our releases by just filtering a certain amount of traffic to different slots. So you can have multiple versions of the code sat by side. And the great thing is Azure Container Apps has a similar concept. It's called revisions, and it works similar, but also slightly different. So both of them allow you to route a percentage of the traffic to the second version. You can also swap back, and it will only swap in healthy apps into the pool. However, app service plans, you create these deployment slots, and then you can copy as many versions of the code into those as you want. So you might have a production and a staging slot. You would put the code into your staging slot, swap it, and then you put the next lot of code into your staging slot, swap it, so on and so forth. With Azure Container Apps, we have immutable versions. So once you specify it, that's the new version, and then we create a new version, or a new revision, should I say, each time. They can both have settings that only apply to that deployment slot or that revision. And because they work slightly differently, your allocations are slightly different. So with an app service plan, you can either have 5 or 20 slots, depending on what SKU you're on. Where Azure Container Apps, you have up to 100 inactive revisions that you can make active at any time. The other thing I want to highlight is about scaling, and I've touched on this a little bit as we've talked through it, but there's a few things I wanted to highlight. So both of them have automatic and manual scaling options, and they can be really useful. It's one of the benefits of hosting a web app in one of these two solutions. I used to work at an e-commerce company, and when TV ads came on, the traffic to the website would surge to many multiples of kind of a standard day. And being able to scale our app and only pay for the compute during that time was really beneficial. They also will remove unhealthy apps if they detect that down to a certain level. But then we've got our differences. So App service plans allow you to scale based on those Azure metrics. So maybe when the CPU or memory on the app service plan, it hits a certain threshold. But when it comes to Azure Container Apps, because they're backed by Kubernetes, they can use CADA scaling, which at the moment that gives you over 60 different scalars, in addition to the HTTP and TCP options. So you could scale on a Redis cache metric and various other options. Also, the app service plans, you scale the number of instances of the app service plan, so all the apps in it scale together, which, as we mentioned before, might not be applicable if you have different parts of a application all in that same app service plan. So example I have is that when I worked at an e-commerce site, the area that people would log in and manage their account didn't really need to scale at the same rate as the purchase, the shopping cart page. Now, because it's all in the same app service plan, we couldn't scale those independently. Equally, you might think about sort of handlers and background processes. You wouldn't necessarily want to scale them at the same rate as you do your front-end UI. So yes, app service plans scales everything together. Azure Container Apps allows you to scale a number of replicas of each of the versions that we previously talked about. And as also mentioned before, app service plans charge even when stopped, and we can scale to 0 if you're on consumption plan on the Azure Container Apps. So that's two of the larger services, or more frequently used ones. I wanted now to talk about Azure Container workloads on Azure Batch. A bit of a mouthful there. What this is, so Azure Batch has been around for a little while, and Azure Batch allows you to take a job, think like a render farm or something like that, break it up into lots of little jobs, and then distribute them amongst many, many computers. Now, traditionally, Azure Batch was backed by virtual machines, and you would use an SDK in your software to split the job up and then to send it off to a number of worker nodes that sit in the pool. And it would then process them. And it works pretty much the same with the containers now that sit on top of those virtual machines. So they do have a wide range of file support, and that's because I imagine that's because they were doing things like MapReduce and render tasks, which are quite file heavy. So we can work with Azure Files, Azure Blobs, NFS, and CIFS, and many others. Some of them are only available on Linux. However, Windows still has support for Azure Files and a few other options. I say the drawback is it's really designed to work with APIs and applications that can split workloads up. So there is limited support inside the portal, and it is ultimately backed by virtual machines. So the use cases for this are parallel workloads such as 3D rendering or HPC tasks, where something can be split up and distributed. That said, Microsoft now recommends for all GPU tasks to deploy them onto Kubernetes, onto a Kubernetes cluster, rather than using a service like this or Azure Container Instances. And I think that's where we're seeing a lot of the Azure Batch work going is towards Kubernetes as a kind of replacement for it. One thing about the Azure Batch service, though, it is actually free. It is a layer that sits on top of the virtual machines, so you're paying for the virtual machines, but you don't actually pay for the batch service itself. So that brings us on to Kubernetes, and obviously we're quite a way through this presentation. I'm not going to explain the entirety of Kubernetes, but we will look at it in a similar context to what we have done so far with the other services. Now, as I mentioned before, Kubernetes is kind of an ecosystem in its own right. You typically use things called Helm charts. It has to configure it. It has its own CLI tools, its own way of doing networking, and various things like that. If you are interested in learning more about Kubernetes and you've not used it at all so far, I can definitely recommend the Cloud Native Foundations set of videos. They do start really really basic with these illustrated children's guide, which is actually quite a fun way of getting some of the basic terminology around, well, what is a pod, what is a node? But they do move on to more complex topics as well. But as I said, today what we're going to do is we're going to focus on the general concepts and align them with the other services so we can do a bit of a comparison. So with Azure Kubernetes Service, we have the actual service itself, and this sits on the outside and it's orchestrating everything that's going on. But that Kubernetes service on its own is not a compute layer. It's just the orchestration. There is a charge for that Kubernetes service. It comes in different SKUs with different SLAs and things like that. But it is just orchestrating what's going on. We then have node pools inside Kubernetes, and this is the compute layer, or a node inside the node pool, should I say, is the compute layer. And inside of that, we have pods, and our containers live inside those pods with any sidecars on them. So that's kind of our structure and layer with them. And because we are using Kubernetes, it is super, super flexible. It's tightly linked to the Azure infrastructure as well. So because we're using Azure Kubernetes Service, what Azure is bringing to this is that when inside Kubernetes you say, I want a new node pool, behind the scenes, that's creating you a new VM scale set, and that's Azure infrastructure. When you configure a load balancer in your Helm chart, you are getting an Azure load balancer behind the scenes, but you're not interacting with that directly. You're managing it through the Kubernetes service as you would any other, as if the Kubernetes cluster was on any other service. So it's going to give you lots and lots of flexibility, but that comes at the cost. I've talked a couple of times about the steep learning curve. And with very small clusters, there's quite an overhead to running a Kubernetes cluster. As we are now a lot closer to the actual infrastructure, you're going to be responsible for patching it, designing the network configuration, making sure it's secure, and lots of other configuration. Now, this can be a drawback, but it can also be a benefit. It really does depend on what you're trying to achieve. So where I see this in use is where you do have a large number of microservices and you have a dedicated team to manage your infrastructure. It's also, when you are managing it, you can then pack more things onto those individual nodes, and you can balance things and manage them as you need. It's also really useful if you've got some really custom requirements. So if you want certain types of virtual machines behind them, if you've got need GPU support and for custom networking and various other more detailed things, is where it can come in really useful. As I say, the Kubernetes service has a free tier, a new automatic tier, and standard and premium, and you're charged on an hourly rate for that. And then you're also charged for the underlying things it creates, such as the virtual machines. So how do we go and create one of these in Azure? Well, it is a bit more complicated than all of the other services, but we start by creating the cluster. Now, I said the cluster is a separate resource to the nodes, but a cluster without any nodes won't do anything. So when we create the cluster, we also specify the node count, how many we want. I've kept this as brief as possible, but there are a lot of options. And once you create your cluster, you get to see all of that inside the portal. So you can see it here. And because I didn't specify, it's just given me a standard DS2 V2 VM. But at the moment, this is just compute. We don't have our application on it. As I mentioned, behind the scenes, that's creating you Azure infrastructure. So there's another resource group that gets created in addition to the one that we specified that we wanted the AKS cluster to be in. You don't have to go into this, but I just wanted to highlight that it does get created. And as you can see here, it's created infrastructure based on its needs there. So we have a node pool, which is a VM scale set. We have an NSG, we have a load balancer, and various other bits and pieces. So how do we get our containers into Kubernetes? Well, There's a number of ways, but this is probably the most common way. So we create a Helm chart, and in that Helm chart, we define the definition of a pod and the image that's going to be on that pod. We also need to be able to route traffic to it. So here we're specifying a service and some port mapping. So that's a YAML definition. And once we've got that, we actually need to apply that into the Kubernetes cluster. So we can use the kubectl, kubectl commands to do that. So firstly, we need to get the credentials from Azure, and then that will allow us to execute these kubectl commands. And here we just apply that YAML file. And this is a way that we really configure most of Kubernetes, is that we apply YAML files in order to add in different settings. We can use this CLI also to examine our pods. And as you can see here, we have our demo pod running and our services, which are our load balancer. Now, you can also see this in the portal. The portal doesn't have a great UI for AKS, and you will often find people using third-party solutions to manage their AKS clusters. But it does give you the basics, and it's quite usable. But what we can see here is our pod is sat there amongst a host of other pods. And these are pods that are running as part of the Kubernetes system. So one of the things I mentioned earlier is if you're only running a single app inside a giant Kubernetes cluster, not only are you managing the patching and the maintenance, the networking, everything else, you have to have your machine is also running all of these other background things that are needed in order to successfully run a Kubernetes cluster. Now, I'm not going to go into any more detail on any of those. It could be many hours of talks just on these little bits. But the final thing I wanted to finish on with Kubernetes is that it's especially Kubernetes on Azure, is that it's part of a bigger ecosystem. So we don't tend to put stateful data inside an AKS. Some people do, and there's a bit of a debate around it, but generally you wouldn't. So you're linking out to other PaaS services such as Azure SQL or Cosmos DB. You're also interacting with things like Active Directory that are outside. It does support managed identities, and it will use the underlying Entra ID now for that. And we're pulling our image from somewhere, which will probably be the Azure Container Registry, although it could be Docker Hub. So I wanted to show you that it's just part of a bigger ecosystem, and it's what the Azure Kubernetes service gives you above and beyond just running Kubernetes yourself. There are also a set of tools and management features that Microsoft are adding in order to make managing Kubernetes easier. So there is the new automatic mode, which I haven't used it myself, but I believe it gives sort of automatic node pools and things like that. So they're a bit more managed. And there are things like fleet managers. So if you have multiple Azure Kubernetes services, you can patch and upgrade them all together. So they're definitely aware that it is complex. They're adding in tools. And that's where ACA really comes in. It's kind of gives you the benefits of a lot of this without that added complexity. So the final service I want to talk about is virtual machines. And you're probably quite familiar with virtual machines. They've been around a very long time. And the thing about these is that they can still run containers, and you get full control over everything, for better or for worse. It could be useful if you want to run something like Docker Swarm. Kubernetes has kind of won the orchestration war, really, but people do still use Docker Swarm, and theoretically you could do that on a set of virtual machines. But you are going to be designing everything, patching, managing it all yourself. You're kind of on your own, really, for that. So when would you use these? Well, probably if you had a migration from on-prem to the cloud, you might do this as a first step. Or if you've got a custom scenario, like we've already mentioned. And virtual machines are charged, as mentioned before, kind of by the size of the virtual machine, charged per minute. So that is a really quick tour really through each of the options, looking at the container instances, the registry tasks, the specialist container supports, the app service plans, ACA, batch, AKS, and finally virtual machines. And as I've said all the way through, these are big topics, and really hopefully this is just a starter, so you can go away and have a look at them, and maybe I've highlighted a few that you might not have known about before. But yeah, if you've got any questions, we can talk a bit more now, or you can find me on socials, as I said, at John Kilmister. The link I'm sharing here is to a markdown file that has a load more links and resources about all of the things that I've talked about today, should you find that that you want to read a bit more about any of these. So there you go.